Today, I'm going to talk about kinematics equations. Actually, three kinematics equation. Let me write three equations first. Then I'm going to explain how to get them. The first one is final velocity is equal to acceleration times t plus initial velocity. Second equation is the delta x position is equal to 1 out of 2 at square plus initial velocity times t another one. The last one is, it's called time independent. Initial velocity, final velocity square minus initial velocity square is equal to 2a delta x. As I said, I'm going to talk about the derivation, how to get them by algebraically. Okay, everything is ready. So kinematics equations. We start with the definition of acceleration. What is the definition of the acceleration? which is delta V over delta T. Do you know the meaning of the delta? Delta means change in the variable. So in this case, delta V means the initial, no, final velocity minus initial velocity. So delta T means final time minus initial time. Then to get kinematics equation, we need to understand the two situations. The first one is the acceleration is 0. The object doesn't have acceleration. So, so let's talk about the situation that the motion doesn't have acceleration. So acceleration is 0. If acceleration is 0, what's gonna happen on xt graph? Xt graph, let me draw the xt graph. This is a t graph. Actually, nothing is very interesting because acceleration is 0. That means acceleration is not changing in time. So the graph of this is like this. Then what happened on VT graph? Let me draw VT graph here. VT. This is a same. Nothing is very interesting because acceleration is 0. That means the change in velocity is 0. So 0 over anything is 0. So A is 0. That means final velocity and initial velocity is same. They are not. So velocity is not changing in time. So in this case, the graph would be something like this. right? The velocity is constant in time. The next, let's do the xt graph. X means position. Position must be changing in time. Position, technically, its position is distance. Distance must be changing in time. Because velocity is constant, not changing, but still the object is moving. So in xt graph, the graph must be diagonal. This is a linear line. So we can express this as a linear equation, linear function. Do you know what linear function is? Linear function is linear function is something like y equal, you guys use x plus b. So even though axes are different, variable are different, we are using x and t instead of y and x. We should be able to express some like this. So because vertical axis is x, so let's use x here. X equal, we don't know m yet. The x variable is t this time, so we use t, which is the horizontal axis, plus b. B is y intercept. In this case, x intercept. So here must be x, initial x. So initial x. Then what is m? M is slope. So in this case, slope is final position minus initial position over final t minus initial t. Do you agree this is the definition of the velocity? Which is delta x over delta t. So here, this one can be written, x equal bt plus initial position. Then subtract initial position from both sides. Delta x is equal to vt. Most of the people must be familiar with this. It says distance is equal to speed, in this case velocity, times time. This is a formula that a student study in elementary school, maybe. That's the situation that acceleration is 0. Now let's talk about the situation the motion has acceleration. But acceleration is not changing. Acceleration is constant. Okay, existence, but not changing. So let's say a equal constant. If acceleration is constant, exists on the motion, what's gonna happen? We're gonna do same thing. AT, we are going to consider on AT graph, BT graph, XT graph. First, AT graph. Let me draw AT graph. This time acceleration is not 0, not going to be like that. So acceleration here is gonna be not very interesting. A is constant, A is A. A is not changing in time, so something like this. Okay. Then let's think of VT graph. V. Let me draw a VT graph here. This time VT, the V is not a horizontal line. It's going to be diagonal, linear line. because acceleration is constant. That means every time velocity is changing. So the VT graph must be. Then important thing is this is a linear line. That means we can express this as a linear function like this. Y equal mx plus b. Okay, let's y equal m x plus b. But again, variable are different. We use v instead of y. We use t instead of x. So v equal m, we don't know yet, t plus b. B must be initial velocity. So v initial. v intercept, vertical axis intercept. Okay, what's m in this case? In this case, the m should be the final velocity minus initial velocity over final t minus initial t, because this is a slope, equation of slope. Are you familiar with this equation? Do you agree this is the exact same with this acceleration? So this m is actually a, which is delta v delta t. So instead of m, we use v equal a t plus initial velocity. This is the first equation of kinematics equation. Next, let's talk about the xt graph. Let me draw the axis or xt graph. The vertical axis is x, and this is t. But it's hard to figure out the shape of the line from this. Then let's go back to VT graph when acceleration is 0. Then look at here. Let's think of the area. This area enclosed by those lines. What does indicate this? What does this indicate? Do you agree this indicates the distance? Because this length is v. This is v. V, and this is t. So the area, the calculation of this area is v times t. Remember, v times t is delta x, which is distance. Okay, so this purple area is distance. So from this, the area enclosed by the V line and T line, then those axes on VT graph is distance. So let's back here. Let's go back to here. On VT graph, when a is constant, acceleration is constant. I believe the shape of this area is trapezoid. Okay. Let's calculate this trapezoid area. If you can calculate this area of this trapezoid, that indicates the distance. That would help to understand the shape of the graph of xt graph. Let's calculate. So to calculate this area is, first we add this length, initial velocity, then here this is a final velocity, this is a t. So v0 plus final velocity times the height of the trapezoid t times 1/2. Then we already know final velocity is equal to at plus v initial. So let's substitute this into this v. So that's gonna be, let me put 1 over 2 first. 1 over 2, then t over initial velocity plus at plus initial velocity so if we arrange this, one out of 2 t times, let me calculate at first. So 1 over 2 at square. Then we have 2 of v0 initial velocity. So 2's cancel out. So second term is gonna be just initial velocity times 1t. So eventually, delta x is equal to 1/2 at square plus initial velocity t. You should realize, if you think t as, if you consider t as a variable, this is a quadratic equation. And this is a quadratic function. Do you remember the shape of the graph of the quadratic function? It's a parabola. So the graph should be something like that. That's how we know the shape of the graph on xt graph when a is constant. So we got the 2 equations of kinematics equations. But as I said, we are supposed to know 3 equations. So 1 is remaining. How do we get that? We use those 2 equations to get last one. First of all, so let's use this guy. v equal at plus v0. We solve for t, then the t is gonna be v minus v0 over a. Then we substitute this t, the right hand side, into the t's on this quadratic function. Then x equal 1 over 2 at square plus v of t. Then the t is not t anymore. It's v minus v0 over a square plus v naught. T is v minus v naught over a. Then let's expand them, which is uh, 1 over 2a. Then inside of the parentheses is v square minus 2v v0 plus v0 square over a square plus let's distribute v0 minus v0 square over a. A is cancelled out. The only one is a. So the denominator a is common. Then let's multiply 2. This is delta x. So multiplying 2a for both sides. So 2a delta x equal to 2 and a is gone. So v square, then this v0 square, this v0 square are cancelled out. So minus 2v0 v0 minus 2. We multiplied it by 2. So this negative 2v v0 and positive 2v v0 cancelled out. So remaining is v0 squared. So finally we get, let me put this guy first. Go to A delta x. Since there is no t in this equation is called time independent equation.